As part of the presentation, we also have representatives from Schaff and Wheeler. They are the firm that provided us the storm drain master plan that council adopted last summer. First of all, there is Dan Schaff. He's one of the principal owners, and also Glenn Anderson, and he's been the project manager during this entire period when the Sinkhole developed. But before I begin on this presentation, I just wanted to say, today of all days, it dawned on me that 6 years ago, I presented a very similar presentation to the City Council for Richmond on the cause and repair of their sinkhole. And that sinkhole, just like Moraga, was challenging. It taxed our financials. It was very inconvenient to the businesses and community. But in the end, we made it through. And so we'll do the same for the town of Moraga. We've been very fortunate, given the gas line rupture, that it did not do any worse damage. So we've been very fortunate so far, but we still have a journey ahead of us. So I'd like to begin with presenting to you the agenda. I will be speaking on the sinkhole background, briefly, the project overview, then passing it on to Glenn to talk about the existing pipe conditions. He's gonna also show you a video of the initial damage observed in the pipe itself. He's gonna talk to you about the parent mode of failure. Then Dan will take over and go through the various repair alternatives that we went through. Then come to the recommendation to replace the pipeline because it is the least risky of all alternatives, and we'll go into more details with that. I'll end with the next steps and answer any questions you may have. So the staff report has a very detailed account of the history with this particular sinkhole. But on March 13, that's when the sinkhole occurred, on the corner of Ream and Center. The sidewalk and surrounding ground collapsed. Underneath that sinkhole, measured 15 by 20 feet by 15 feet deep, is a 96-inch corrugated metal pipe that channels the Laguna Creek. It flows from the north to the south. In the little figure in the presentation, you can see the red dot identifying the location of the sinkhole. 10 years ago, another sinkhole did develop in 2006, and that's depicted with the blue dot. So this is a bigger overview of the project site. The green circle shows you where those two sinkholes occurred. And I say that because later on in this presentation, you want to know where these landmarks are because it'll help us when we walk through that culvert and start identifying the different damages. The blue arrows there show how the creek flows. The line is the pipe system. Those in yellow are concrete, while those in red are corrugated metal pipe. And as you can tell, that line runs underneath the Ream Shopping Center. Now I'm going to pass it on to Glenn to talk about the existing pipe conditions.
Thank you, Edric. As was mentioned, my name is Glenn Anderson with Schaff and Wheeler. When the hole was deemed safe for us to enter on March 25th, myself and a consulting geologist made our way into the pipe to inspect what happened and what was going on. And so I'll just kind of walk you through what we observed in the pipe when we got in there. The first thing you see is extensive corrosion of the bottom of the pipe, or the invert of the pipe, as it's called. In certain places, it was very Swiss cheesed, as shown in the bottom picture. In other places, it was completely rotted through, completely separated the sections of the pipe. In locations where it was Swiss cheesed, we were able to measure voids below the pipe of up to 15 inches deep and extending 2 feet to either side of the center of the pipe. So pretty big void below the pipe. In addition, we also saw severe deformation of the top of the pipe, or the crown of the pipe. And that's very obvious in figure 6, shown here. You can see this pipe, when it was put in the ground, was a circular 96-inch diameter pipe. And you can see the ovality of the pipe here. Also in the pipe was evidence that the sinkhole had made its way into the pipe, debris, We saw valve vault lids and, as shown in the picture, electrical conduit from the sinkhole itself. What we see here is kind of the epicenter of the sinkhole. The ladder represents where we've accessed the pipe through a storm drain inlet above at the corner of Center and Ream. On the right side of the ladder, you'll see a significant joint offset that measured 17.5 inches wide. At that joint offset, as you see kind of zoomed in figure 8 on the bottom, there was pipe from the sinkhole, sidewalk sections, irrigation pipe, all that had been sucked down towards this joint offset. In addition to that, even though it had been dry for 10 days before getting into the pipe, there were still 1 to 2 gallons a minute of water flowing into the pipe. So water still making its way into the pipe. While we were in the pipe, we did as thorough an investigation of the pipe within the town's right-of-way as we could. We went from the north end on the Auto House property to the south end, the town's right-of-way. This table just highlights what we found throughout that. A couple things to highlight. Remember I said this was a 96-inch circular pipe when it was installed. You can see in 2 locations the height was reduced down to 78 inches high. So it went from 8 feet to 6.5 feet in height. The next slide we'll talk about, it's a similar table, but just to give you some reference for where these things at. Station 0 plus 45, as we've called it, is the sinkhole location. That's where we were accessing the pipe. That's where the joint offset occurred. 45 feet to the north of that on the Auto House property is where this metal pipe transitions back to concrete pipe. And at that location, there was a vertical offset between the 2 pipes. The metal pipe was 5 inches higher than the concrete pipe. And what that did is that allowed water from the concrete pipe to flow below the metal pipe. 71 feet south of the sinkhole is a visible joint offset that was patched when the sinkhole of 2006 occurred. This we believe was where the sinkhole happened at that time, and temporary repairs were made to deal with that. So with this little bit of background, we've got a dark video from within the pipe. I'll kind of narrate it for you, and we'll go from there. So that we started at the south end of the pipe where those temporary repairs were done in 2006. You can see the floor of the pipe was covered in concrete to deal with the corroded bottom. You can see, although not discussed anywhere before, joint offsets. And as we're heading south, so we're heading north, so we're heading up the pipe. This is the large joint offset that was noted 71 feet south of the current sinkhole. That's where the temporary repair for the previous sinkhole happened. As we continue north, you see more concrete patch on the floor. And again, as the further north we head, we see more joint offsets within the pipe. And continuing further north, the concrete patch on the floor ends, and you can actually see the bottom of the pipe is gone. There is no bottom of the pipe. Kevin, the geologist, was standing in gravel that is not within the pipe. There is no bottom or invert of the pipe. You can see debris washed in, and here you'll see him reach down and actually pick up some of the gravel. That's a very good example of the pipe bottom being gone. Now there's the ladder that we use to gain access, and we'll come up and you'll get a video of there's the joint offset where all of the debris and soil was able to make its way into the pipe. That's the access point above, which is a concrete structure sitting on top of the pipe with a drop inlet or a storm drain inlet on it. As we continue north, we're still in the metal pipe, but you'll continue to see joint offsets and failing bottoms of the pipe, failing invert. Here you see a complete separation of the pipe on the bottom. We're coming up to this point here when you can actually see there's a 1 foot about vertical lift of the bottom of the pipe where it's somewhat collapsed around itself. You can see water flowing below the pipe about 15 inches to a foot deep here. And we continue north, and it's more of the same until we get to the concrete interface. And I think it's important to say, I said earlier, we're heading north and going uphill. And you'll see it here in a second. When Kevin actually steps into something that is supposed to be uphill, you'll notice he steps down about 5 inches into the pipe. So that's supposed to be a higher portion of the pipe, but it's lower. So now seeing everything we've seen, what caused this? And so basically this sinkhole was preceded by 8 days of rain. Combine that with the corroded invert of the pipe, the corroded bottom of the pipe, as well as loading on the pipe, and it allowed the pipe to deform. That deformation created this big opening that all of the water from the storms making its way to this site was able to wash the dirt and the materials in. This is a little convoluted, but I've got maybe eyes glazing over, but hopefully this next animation shows it clearer. So we've got the installed condition. We've got a nice circular pipe with this inlet sitting on top of it and some water level. As time goes on, the bottom of the pipe corrodes and a void is created, and this grows and grows. So that's orange is the corroded pipe and green is the void. As that happens and the pipe is loaded, the pipe is allowed to deform around itself, somewhat fold in on itself. It does that, and it creates this crescent shape here that you'll see is a blue, and that's that joint offset that I was talking about. That's that 17.5 inches that lets soil come in. Now, as that happens, and now we've got rain, and so we've got water making its way into the pipe, pulling soil with it, more and more soil, eventually, a void is created. Should show up. So you have this void, and as more and more soil is pulled in, this void gets bigger and bigger, and eventually the soil above it and the sidewalk can't support itself anymore, and that's the collapse you get. That's what we have here. This is the day after, where this is the sinkhole with the traffic light still in it. You can see the sidewalk failure, and on the next slide, this is taken from the La Marinda Weekly, just talking about the spaghetti bowl of utilities that we have. You can see the cable fiber optic lines are those orange things behind the inlet structure. There's a PG&E switch, the foundation for the traffic light, other storm drain facilities, all in that hole. And then fast forward to what we look like today. The site's been secured. There's temporary fence put around it. The I-beam is holding up those fiber optic cables so that everyone in the town of Moraga has internet and cable TV. Plastic's been placed to mitigate any impacts that rains may have in terms of expanding that sinkhole. So that's where we sit today. I'll hand it off to Dan Schaff now to talk about alternatives.
Thanks, Glenn. Again, I'm Dan Schaff. I'm an engineer with Schaff & Wheeler. I'm also one of the owners. You may recognize me from the Storm Drain Master Plan that I presented last summer. So tonight I want to talk about how we move from here, what alternatives we have and what we looked at. And just real quickly, we looked at 4 things. We looked at really sort of almost a do nothing. Let's just secure the site and move on, see what happens. The next is to kind of take advantage of some newer technology called Trenchless Technology. Instead of unburying, digging up the existing pipe, can we use newer technology to slip line a pipe into the existing hole, minimizing the traffic impacts. Then the full, the other end of the spectrum is channel restoration. Let's bring back Laguna Creek for this 120-foot section, kind of daylight it, a little more natural. And then lastly, we'll talk about just replacing the 120-foot section of pipe with brand new reinforced concrete pipe. So the first one, this is really the do-nothing repair. The idea here is just simply, let's build a fence around the existing sinkhole, have a celebration or whatever it is annually, and maybe the celebration will get bigger as that hole gets bigger, because that's exactly what will happen. So about $500,000 just to secure things in place and see what happens. Obviously, we're not fans of this. There's incredibly high risk doing this. not only will the sinkhole grow, but we believe the pipe is going to fail. That will block flows. We'll probably experience flooding upstream and in the area. So very unsafe, very unreliable, not recommended. So I talked about slip lining. This is also called trenchless technology. This is kind of the newest, greatest thing for engineers. We don't have to dig a deep trench. We can slip line a pipe. So the figure shows a green pipe inside the mangled CMP pipe. And the advantage is not ripping up the road. A little bit cheaper to do. We estimate this about $2.5 million. However, that slip line pipe has to fit in with that opening, and Glenn mentioned that opening is only about 78 inches, so 6.5 feet. So we're going from an 8-foot pipe to a 6.5-foot pipe. So we're losing 33% of our conveyance area, our flow area. Therefore, we don't think that pipe will have capacity to pass Laguna Creek downstream. So there's a high potential for future flooding if we get a large storm event. The other thing to mention is that those voids that are out there in the soil also need to be filled. And there are methods to go through and measure that. They use acoustic hammers and things, but there's no guarantee that we will find all those voids and fill them. So there is still some potential for sinkholes in the future with this alternative. Next is to restore Laguna Creek across this intersection. So we're talking about a 120-foot section, and we still need a bridge to pass however many lanes of traffic is. So unfortunately, it won't look like the picture on the upper right. It'll look like that, but much deeper. We're talking about a 30-foot hole, and we have water coming out of a 96-inch pipe going very fast, so we can't use vegetation in that channel. You would see lots of rock to slow down the flow. It's basically a spillway type thing where water's coming very fast and you need to slow down, and then immediately it's gonna go back into another pipe. So estimated at about $20 million. We don't know the extent of the realignment of the roads and who owns the easements. Lots of permitting, and very important here that this is not eligible for federal emergency funding. So very noble to try to daylight the creek, not the right place for it. Okay. And lastly is to simply remove the corrugated metal pipe within the public right-of-way and extend the 96-inch reinforced concrete pipe to the extent of the public right-of-way. We estimate this project at about $3.3 million. We believe it'll take about 6 months from now, including design and construction. But what's important to note here is this restores 100% of the capacity of the pipe, actually a little bit more than the corrugated metal pipe, because corrugated metal pipe is kind of rough and concrete is very smooth. This has incredibly low risk of future sinkhole failure. If we were to design a new pipe from scratch in a new community, this is exactly what would go in the ground. So kind of just wrap up real quickly, those 4 things we talked about. We talked about doing nothing. It costs $500,000 and can almost guarantee you're gonna have problems in the future. So to that we say, no. Then using some of the trenchless technologies, saving about $800,000, but reducing the conveyance in that system, so increasing the risk of flooding, and also not knowing, there's still that uncertainty about sinkholes. Not as great as the others, but there's still that risk. So for that, we're saying no. And then daylighting the channel, again, not the right place for this. It's very noble to try to do this, but it needs to be done on a much larger scale to be economical. So to that we say no, which leaves us with replacing the pipe with reinforced concrete. And the next slide goes into, again, this is what we're recommending. Again, it restores 100% of the capacity of the original design for what Laguna Creek will pass. All the soil is removed, we put in a new pipe, we backfill it, so there is gonna be no voids. It's concrete pipe, it's solid, it's non-corrosive. In a stormwater environment, this pipe could last easily 1,000 years. And also it's very strong, it can handle the loads. So one thing I also wanted to point out is that we're not only fixing the current sinkhole, this extension of the pipe would cover the 2006 spot repair, the Band-Aid that you saw earlier. So the construction window, we're estimating about 3 months, so about 3 months of disruption to trench that and put in a new pipe. And with that, I'll let Edric tell you where to go from here.
Thank you, Dan. So as you can see, a recommendation is to replace the pipe with a reinforced concrete. A lot of very good benefits and the least amount of risk as described. If council does concur with this recommendation and council directs staff to proceed with the emergency repair, we will hit the ground running right away. We will begin our design of the repair project itself, prepare bid documents, begin right away in looking out for potential contractors, seeing if they're capable, able, pre-qualifying them to see if they have the experience that we need, and then bringing them along during the design process at various submittals so that they are aware of what they're getting into and so that they can also provide a very quick turnaround in providing us bids. All of this will be done within a month. So quite a lot of work in a very short period of time, but this is necessary because we want to beat the winter season. And so once that happens, we'll bring back to council on June 8th to award the construction contract. Also at that time, we hope to learn a lot more about the financial plan and what it means to be under the governor's proclamation. We began conversations already. Just today, we got an email from Caltrans, and so the next step is to set up a meeting with them and understand what the process is and how much we may be able to get. So at that point, once we understand the financial plan, we can also appropriate the funding that we need in order to do the repair. It takes approximately about a month for the contractor to get all of their contracts together, their submittals, to start looking at staging areas and things of that nature. And generally speaking, we'll be able to do a notice to proceed about a month after council awards. 3 months into that, October 8th is when we'll end construction, right before October 15th, the beginning of the rainy season. So with that, that's the conclusion of the presentation. I want to first thank the community. They've been immensely patient. The businesses, the residents, the detours, and all of that. And so we've been very appreciative of that, as well as the town council for the guidance during this emergency. And lastly, Senator Glazer and Assemblywoman Baker, their support letter that was provided to the governor did help us significantly get that proclamation. So thank you to all of these parties.